Semiconductors Changing Our World by Scott Seary, Benjamin Faduzkar, and Eddie Brown. In the semiconductors, many engineering disciplines are needed. Mechanical, robotics, and electrical engineers are all used in different capacities. Mechanical engineers design and build the machines for the different processes and automation. The robotics move the wafers from machine to machine, process to process without being contaminated by human error or by human particles. The electrical engineers usually do the processing and making sure that the electrical properties of the wafers and of the semiconductors are in spec and to what the customer needs. Electrical engineers use statistics in a variety of ways, but one of the most common ways is by using the range to be able to get the high and the low values of resistivity, uniformity, different types of variables on the wafers. They'll use that, and they'll use a standard deviation to be able to come up with statistical process charts that are used to monitor each and every wafer of a project so that they can control the quality of the wafers better and notice any shifts that may be caused by a mechanical error or contaminated gas or for any reason at all. In semiconductors, mechanical and robotic engineers cover a lot of the same statistical analysis. Mechanical engineers will record hours to failure of mechanical systems and then use statistical inference to design preventative maintenance schedules to replace out parts. If something wears out, then we will know when to replace it. The robotics engineers do a lot of the same things. They have structural hours that they need to record, so they can also use statistical inference to predict when not only electrical parts will go out on the robots, but when they become structurally unsound. On the back end, the statistical data is taken on the wafers to ensure that the process came out correct. The batches are inspected for yield to see how many are done correctly and in spec and function well. If there's a problem with that, the statistics are used to go back to the mechanical and robotic engineers and find out where the breakdown in the machines had occurred, whether or not that it was a structural, electrical, or a robotic failure that caused the yield to be bad. So in the end, they are all working together to ensure that the semiconductors and the parts that they produce come out correctly. Semiconductors help create a better future by helping to solve some of the 14 grand challenges for engineering. They help by advancing solar panels, because solar panels are actually a semiconductor process that causes the transfer of energy from the sun to a battery. Semiconductors are used in all computer applications, so it can help computers reverse engineer the brain, help in health informatics, combat nuclear terror in a whole bunch of ways. Virtual reality will be all computer based. Personal training, there is a lot of internet learning going on right now, and it'll only get more and more advanced. And then a lot of the tools of scientific discovery have electronics in them, which with better semiconductors will be able to have better computers.